Welcome everyone to this lecture on the left outer join, otherwise known simply as just a left join. A left outer join results in the set of records that are in the left table. If there is no match with the right table, then those results are null. Later on, we will learn how to add where statements to further modify a left outer join. So, what does a left outer join actually look like? Here, notice that our Venn diagram is no longer symmetrical, which means the order will actually matter. Here we're saying select everything from table A and do a left outer join on table B. The left-hand table is the first table referred to in that from statement. So that's why table A there is seen on the left. So we're saying select everything from table A left outer join on table B. On table A.columnMatch is equal to table B.columnMatch. So notice we're essentially just grabbing information from table A where there's either exclusive to table A or table A has a match with something in table B. If something is only found in table B, then it is not going to be returned in the query. And again, recall that a left outer join can be shortened to just left join in SQL syntax. So it doesn't matter if you use left join or left outer join. Now because of this asymmetry, this is where beginning students often get confused. Previously, everything we saw, it was symmetrical in that Venn diagram, which means the table order didn't matter. When it comes to a left outer join or a left join, the order does matter because we have to actually specify what the left table is going to be. So notice here we're saying table A, which means we're going to grab things that are exclusive to table A or can be found in both table A and table B. We are not going to be returning anything exclusive to table B. So again, not returning anything exclusive to table B. So let's explore a left outer join with our two example tables. Here we have registrations and logins. So what we're going to say here is say select everything from registrations, perform a left outer join on logins on registrations.name equal to logins.name. And what does this actually look like? Well, it's going to return the following. Recall that we're going to grab everything from the registrations table, and if there happens to be a match with the logins table, we'll go ahead and return it. If there is no match, we're still going to grab that information from the left-hand table, which is from registrations, but because there's nothing in table B for it, we're going to fill it in with null. Notice that things that were exclusive to the right-hand table, that is the logins table or table B, that was Xavier and Yolanda, we don't actually see them in this result of the left outer join. Previously, when we saw a full outer join, we did see those results. But now, because we're specifying a left outer join, we only see things based on that left-hand registrations table. It either belongs to both tables or only to registrations. If it only belonged to logins, we don't see it returned here. So again, everything from registrations ends up showing up in this left outer join, which is why it's critical to remember that table order does matter in the SQL query syntax when it comes to a left outer join or a left join. Now we can further qualify this with a where statement to get rows unique only to the left table. So for instance, what if we only wanted entries unique to table A? Those are rows found in table A and not found in table B. So we're essentially just grabbing rows unique to table A, not found in this other table. So the way we do that is by saying the following. We're going to again select from table A, do a left outer join on table B, specify the column to match on, and then we're going to say where table B is null. Because if table B is null, that means the resulting rows would only be unique to table A. So recall this was our previous query. This is just the left outer join, registrations and logins. And what we're going to do here is if we take a look at the login ID column, we notice we have those null values. So what we're going to say here is go ahead and grab where logins.logid is null. And because the logins ID, that is from the right-hand table or table B, was null, this answers the question that these particular rows are exclusive to the left-hand table or the registrations table. So Charlie and David can only be found in the registrations table. They cannot be found in the logins table. So this is a left outer join with an additional specification to only grab tables unique to the left-hand table, that is table A or registrations in this example. So definitely take your time with these and feel free to watch this video a couple more times. Sometimes it takes students just a couple of times of watching this video to truly get the understanding of a left outer join. This is the most complicated join because it is a non-symmetrical join. So let's see some examples of a left outer join in pgadmin. If this is still a little fuzzy to you, I would highly recommend that you go back, watch this from the beginning, just let things cement theoretically, and then come with us and join some SQL queries in pgadmin. Okay, I'm going to hop over to pgadmin now. All right, the two tables we're going to be exploring for this particular example is the film table, which I can just select everything first from the film table so we can get an idea of what's in it. So I run this, we have a film ID, which is a unique identifier per film, the film's title, a description, release year, language ID, rental duration, etc. So we have that information here, basically information about the film. The other table we'll be taking a look at is the inventory table. So the inventory table, if we run this, it basically has a unique inventory ID, and then the film ID, which matches up with the film table, and then the store ID. So essentially this says that we have film ID 1 located in store ID 1. And then we have another repeat, essentially a duplicate copy of film ID 1, also in store ID 1. So this essentially begins to imply that we have multiple copies of films in certain stores, and we also have the possibility of films only being located in one of our two stores. So let's start exploring this. Keep in mind, each row in the film table may have 0 or many rows in the inventory table. So for example, we have film ID 1 is currently in inventory both in store ID 1 and store ID 2. So we have lots of copies of film ID 1 in both stores. So what I'm going to do is the following. We'll say select film.filmID, film.title, and then inventory ID. So the reason I don't need to specify inventory ID of a table is because it's unique to the inventory table. However, film ID can be found in the film table. And in fact, title is actually unique to the film table, so I don't need to mention that as a table as well. So we have select film ID, title, and inventory ID. And this is where we're going to do our join. We'll say select from film, left, and you can say either left outer join or just left join. Those are syntax-wise the same thing. And we're going to say inventory on inventory.filmID equal to film.filmID. We run this and note what we're having here. It's basically telling us the film ID, the title that belongs to that film, and then its specific inventory ID. And if I wanted to, I could expand on this by asking for also the store ID. I could run this again, and I can see we have Academy Dinosaur, multiple copies in store 1, as well as multiple copies in store 2. So that is a left join, essentially showing us the left joining of film on inventory. So what does that actually mean? Because film is on the left-hand side, I'm only going to see rows that are either in just the film table or in both film and inventory. Right now, I am not seeing any films where they happen to only be in inventory for some reason, but not have some sort of title attached. So because some rows in the film table do not have corresponding rows in the inventory table, we would see that the values of the inventory ID are null. So there's lots of rows here, but eventually as you scroll down, you may find something to be null. So what I'm going to do here is show you that. We're going to say where the inventory dot film ID. Note here how I have to specify the table for film ID because it is found in both tables. And I'm going to say is null. I'm going to run that. And often you also see null be in all caps. So keep in mind, you can also just do all caps null. run that, and it looks the same. It's up to you whichever manner you prefer. But what is this actually showing us? This is showing us a film ID, a unique identifier for the film, as well as the title, and is showing you that we don't have this in inventory, which means essentially if someone comes up to us and they ask, hi, where or what store can I find Alice Fantasia in? We can do this query, and it basically answers it that we don't actually have Alice Fantasia in our inventory. In fact, we don't have any of these movies currently either in our inventory or in any store. We have information on them. I can tell you the release date or the actors in them, etc. from the film table and maybe doing other joins, but unfortunately right now we don't have them in inventory. And so here you can begin to see the use case for a left outer join, essentially showing us films that we have information about but that are not in our inventory because we're specifically checking where that inventory film ID is null. Okay, so that's it for this lecture on the left join. Keep in mind, we're going to get more practice on this with your challenge questions, so feel free to review this lecture as many times as necessary. Thanks, and I'll see you at the next lecture.